say, man, goodness, sure. So here we go. This is three new derivatives. This actually has absolute value in it also, and absolute value. Did you talk last year? I don't know if Ms. Karen touched on this. Did you talk derivatives of exponentials last year? Do you know how to take the derivative of 2 No? Yes? Okay, I'm getting a little bit of a mixed signal. Well, the good news is I'm not going to tell you either way, so you figure it out. Go.
So it's e to the x ln of q, which is the normal one, so it's going to be 2 to the x ln of x. I think. No, ln of 2. Yeah. I think that's what it is. No, you're right. E to the x ln of q. But ln of the q. Okay. Ready? Do I sound right? I feel like that's how do you like approach it? I don't remember how I can figure that out. I just know what the answer is.
I would say if I don't like x up there, what could I do to bring it down?
It's like a log.
That might start you.
I remember we did learn it last year. Why is it actually?
Okay, ready? What's one thing you can do to get rid of it? Assuming you don't remember the derivative. Okay, one way, just general rule of thumb, and this actually applies in a lot of layers anytime you're dealing with exponentials. If you don't like the x up there, do something about it. Take the log of both sides. That allows you to move that guy down. You have log of y equals x times the log of 2. Then you can differentiate vocabulary. Implicitly, beautiful. The derivative with respect to x of both sides is 1 over y. dy dx is, what's the derivative of that? Do I need the product rule? No. Could I use the product rule? You could. And the derivative of log of 2 is 0, so it would be worthless, but it is just, it is, but it happens a lot. People think log of 2 is a function rather than a number. Crazy, isn't it? Dy dx is, therefore, y log of 2, but if we put the answer in terms of x only, then y gets sub 4 with 2 to the x. So the derivative is 2 to the x times the natural log of 2, or generally speaking, a to the x times the natural log of a. There's at least another one way to do it if you like. Some people might say, I'm going to write 2 as e to the log 2 to the x. You could do that and differentiate with kind of a chain rule kind of thing. Y prime is e to the log 2 and x times the derivative log of 2. And this then is 2 to the x. That's at least a couple ways to skin a cat, that kind of thing. All right, try the next one, the log. There's more than one way to skin a cat? That's a sin. No. Kind of makes me look.
X equals 2 to y, maybe? No puedo hacerlo, hijo. Yeah, that just doesn't make sense. Michael. Hold up, Michael, let's see. I mean, max out is just exponentially. Like x equals 2 to the y, but like that's not solving anything. Okay. 1 over x natural log 2 by whole. Only 2. 1 over x ln 2. Sick, dude.
Ready?
You can do what we just did.
Okay. Sorry, it's just let's make sure I have the same slide. Okay.
Oh my gosh, I think I have it.
You got it? Okay, so the same couple ways to go. They have the first same step, which is to exponentiate. I heard that a couple times, and that's definitely the way to start. One way to go here is, well, shoot, that's exponential now, so use the idea you just did. If I take the derivative of the left-hand side, it's 2 to the y natural log of 2, but then implicit times the derivative of y is dy dx, yeah? Over that side, the derivative is 1. Therefore, dy dx is 1 over 2 to the y natural log of 2. Unfortunately, then 2 to the y needs to be fixed. What is 2 to the y in terms of x?
Just x. It's just x.
Oh yeah, it's x, so boom.
Oh no.
I guess that's easy. All right, so that's one way. Another way that I heard, at least I think these guys said, is if you take this and then take the log of both sides, that allows you to bring the exponent down, yeah? Y log of 2 equals log of x. Did you then solve y is log of x over log of 2? And then finally, I haven't even differentiated yet. I've just done a whole bunch of algebra so far, right? So then dy dx is 1 over x natural log of 2. Either way, you get the same result. So, generally speaking, the derivative of log base a of x is 1 over
1 over x ln of a.
x natural log of a. Okay. This, by the way, this field of mathematics, so, you know, proving terms, coming up with terms, is analysis. And when you do math analysis, you're doing proofs of math ideas. Calc analysis is pretty fun to do, actually. All right. What's got going on here? Why are you so low? All right. Am I in the right place with my notes now?
What?
Did I miss the question?
Seems if we have.
Oh, okay. Would you do that that example at the bottom of the first page? And I'm going to add that in. Or that question. Do I have? No. Where did it go? Open. 72.
Getting interrupted. Let's think about that one, Michael. Third, it's supposed to be right here. What? Maybe not. Natural log of a half is always going to be negative. And then x always has to be greater than 0 because you're taking a log of something. So you can't take a log of negative.
Okay, how we doing? Do you agree, first of all, that by the rule we just said, the derivative of log base of half of x would be 1 over x natural log of a half?
Yes.
We know, hopefully we know, that natural log of a half must be negative, because e only to a negative power would be a half.
Yes.
Do you agree? Okay. Analytically, graphically rather, what does log where the base is less than 1 graph look like? Like this.
I didn't like it. Not like you. Got told you something.
Right? If the base is more than 1, it looks like that. If the base is less than 1, it looks like that. If A is greater than 1, if A is less than 1, those slopes, derivatives are slopes. Aren't those slopes all
Yes.
negative? What's the graph of log base 1 look like? That's if the base is greater than 1. That's if the base is less than 1. What if the base is 1?
Ooh, that's an interesting question.
To be what? 1, you're close. Not just 1, it's
I love it. I don't like it very
well, come on, people.
much.
X is
Why?
y to the first, right? So what does that graph look like? We also call this,
Wouldn't it be x
oh,
equals 1
wait a
to the y?
second, did I,
I feel like it'd be x to the 1 to the y. Or x of 1 to the y. When you exponentiate.
x to the,
Or x equals 1 to the y.
x equals
'Cause when you-
1 to the y, base,
Yeah.
sorry, you're right, sorry. That's why it didn't look familiar, because it's definitely not a line.
I was-
1 to the, sorry, x is 1 to the y, yeah?
Yeah.
So what does that look like?
What is
Yeah,
x equals?
you tell me. If y is,
That's a joke. It's still 1.
yeah, anything, it's, x is always 1, right? Are you with me? Okay, cool. So it's either on this side, that side. I don't know, just, don't know if you ever thought about that. All right, last but not least, absolute value graphing. All right, did you do absolute value derivatives last year? All right.
I'll figure it out.
Okay, you can sum it up pretty much in one word. It's piecewise. Now, there actually is an algorithm to do this, and we'll talk about that later, but for now, the basic idea is to do this in piecewise. So, if you do, is this what your notes look like, absolute value outside? Do I have that right? Okay. If you have absolute value outside, then let's do an example. Say f of x is, let's go x squared minus 4, which I think comes later,
Yeah.
down here. What does that graph look like?
It's going to be a parabola.
A parabola that would want to be shifted
Down 4. But that's
down
not
4,
happening.
so it would want to have a y-intercept of -4 and x-intercepts of 2 and -2. But then the absolute value would take hold and make all y's
Also,
positive. So you'd have a relative max at 4 instead of a min, and you'd have two relative mins of 0 at -2 and 2, right? Okay then. Here's, oops, sketch the graph, check. Okay. Now, in order to take the derivative, you will actually want to do a rewrite step as a piecewise. I'm going to take that function and rewrite it piecewise. I like to go left to right. So the left-hand part of the graph, before -2, y was positive there, and the absolute value did nothing to it. And so as far as the y results there, they're just straight up normal x squared minus 4. They're, you know, at -7 and stuff, I get the same old parabola for x is less than or equal to -2. What about for x's between -2 and 2? Those aren't the normal. Because of the absolute value, those got negated. And so if these parts are opposite y's, and that means the opposite of x squared minus 4, which is to say negative x squared plus 4, or 4 minus x squared, if you like, whichever you prefer. Now that's between -2 and 2. Now I included the endpoints on the outside branch, but you could definitely include it on the inside branch. It's continuous, so I don't care which one you include it on, but only one, not both, right? Last but not least, the far right branch. What is it?
x squared minus 4.
X squared minus 4. Now, you could you know, keep that same branch here and do two different domains there, and I would take that. I think this is better myself, and so that's the way I'm doing it. But I would take, if you wrote this as two functions and had a two-part domain to that first one. With me? All right, now, this is pretty common sense-ish, but it's got one little gotcha to it. When I take the derivative of a piecewise, it's also piecewise. Each piece has its own normal derivative. What about the derivative of x squared minus 4 then? 2x, okay? What about, though, the domain? From all x's up to and including negative 2? Not including negative 2. Not at negative 2 because sharp turn. The slope goes just like that from negative 2 to positive 2, and so that's a no-go. Okay, so on the domain, yes, negative 2 is a point on the graph, and so in the original function it is included, but on the derivative, it's not. The derivative doesn't exist then. The next piece's derivative is negative 2x from negative 2 to 2, not inclusive because there's a sharp turn there, and then back to positive 2x for x is greater than 2. Good? Okay, try these two then on your own, or with your math amigos. Perhaps help before writing this piece.
I was just taking the derivative of x. I feel like it's like it feels like that'd be continuous. Negative 3 times x plus. Yeah. I don't know that for sure, but like based off my graphical skills. Well, you can just do this. Take the derivative of wait. Take the derivative of 1 from the left. I know it's not, you know, same test Michael, right? What? Yeah, it's going to be 0. So that's good. So you can. It is super continuous. How so it's just
Do you agree with the first one? Yes?
I like that.
Okay.
But we don't have the second one.
You don't?
We didn't also have like the first thing at the top too.
This one's so much better.
Yeah. Yeah. What?
Okay.
I'll just try it.
All right. Uh,
Is there a shift? Oh, there's no shift. It's not.
so, I don't want to teach it today. I'd rather you get this method first. But there is a way to do this derivative as a single function. It actually involves a limit that you're really familiar with. You've done a million times, but we'll talk about it later. For now, let's just sum it up. So what's the derivative of an exponential?
A to the x element of x.
A to the exponential log of a. What's the derivative of a logarithmic function?
1 over x log a. Or natural log a.
Log of a. And what's the general method for finding the derivative of an absolute value?
Piecewise function.
And then the only gotcha is make sure that you be careful with corners and cusps. Okay, it is possible, I will warn you, it is possible that, in fact, it's actually on this previous problem, it is possible that you could maybe include those endpoints. In fact, I'm glad I just said that because our answer to that previous problem was log this x cubed at 0. What does the graph do at 0? It is.
Derivative is 0.
And so if you took if you took absolute value of x cubed, it is flat. And does the derivative exist there?
Yes.
It does. And that is exactly what's going on here. It's smooth there. The derivative is 0. There, I know my graph looks like a sharp turn, but it actually is really momentarily smooth. And so it should be included. It is differentiable here. This is included because f prime is 0 at that flex point. At x equal 1. Okay. If the derivative goes flat there, then it'll be flat both sides, and you will include it. That's a pretty rare case. All right, you ready? Are you with me?
Yes.
All right. Let's go to now. I gave you back review 13. I just gave it a quick look, though. I didn't really look for quality. So, is there anything on review 13 that you don't feel comfortable with that you'd like to talk about? Then maybe we can get through 69, 70, and at least feel like we have mastered those two. 13 questions. Anything in there that you could not do on your own on Thursday?
13 is
If you're
pretty
good, that's fine. You've had lots of kids.
13 is
Good?
good.
13, that's what I gave it to you, right?
13?
You up? All right, so we're okay then?
Yeah.
Okay, that's fine. 69, 70?
Sticky, man.
Other questions or questions on 69, 70? 12? Did you say 70?
Yeah, I think 12 totally.
70 question. Oh, sorry, I forgot this is mixed. 71 is 12 on 69 or 70?
12.
69, 12. 69, 12, 71. What? Choose a replacement. Okay. Okay.
Yeah, 69, 17, 18.
69, 17, 18, and 18.
Oh wait, I'm not on the right one. Just kidding.
Okay, so that two is not. Okay, 69, 17, 18. Yes, 11, 12, and 17.
Yeah, 7.
I got
12 was already on
I
there.
got 12 here, so 69, 11. Okay. 69, 21. Okay,
70.
got them up. 71, 74. What about 13?
Okay, let's just get started.
Okay,
I'll read all of them.
that's a good list.
It's hefty.
Yeah, that's something. Okay, 69, 12. Yeah, I didn't do much for you key-wise.
12, it's just like the last interval.
Just the last part
Because
of
you're
it?
adding intervals, and I just couldn't figure out the last one.
Okay.
It's just a really big integration.
Okay. So I understand you right. The first two integrals were okay. It's the third one.
Yeah.
Okay. X. Yes, the third one's hard. Okay. So the first thing that I would throw through my head is U sub. Well, U sub would mean U is this, and this I wouldn't write this down because this all got me nowhere. It feels like a power mismatch there.
Right, which is what I tried to do.
Okay. So there's got to be something else going on here. And that's why you really kind of have to think outside the box. What other kind of derivative gives you that 1 over a root 1 minus kind of thing?
Inverse sum.
Yeah, okay, so that's the way your mind should go. It is a U sub, but not in that sense. Think, I know that this is arc sine, or inverse sine. So the question is, all right, can I make that happen? Well, if you do, then this, how does that work? Well, that seems that U would have to be
X squared.
x squared. Now that feels like that's going to work because that power-wise, I do have x to the first, which is to say, if I substitute that way, then it becomes something like 1/2 du, which obviously you can move that 1/2 out front, then 1 minus u squared. And so that one, that's the way to go. You get something like 1/2 of arc sine of u, which if you sub back is x squared. Does that make sense?
Yeah.
All right. 71. Is that a question? Whoever asked that, are you still with me? 71?
Oh, sorry.
Yep. Or
No, I would, if you just gave me the work without the use of, I would do it. Yeah, that's a good question. 71 is a yes?
yes.
Okay. 71. Oh, yeah, this is I'll need more, okay. So, if I recall, they said two adjacent fields, this one is a tough one. Two adjacent, or not adjacent, sorry, they don't share any sides. I think the square is y by their direction, and the rectangle is x by 2x. Is that correct?
Yeah.
Okay. And if they also tell you that the amount of fence you have is 340 meters. All right, now, optimize the area. Now this one, whether you know it or not, they're trying to help you here, because most people would look at this as a relative extremal problem, and it's actually an absolute extremal problem hidden in here. They tried to help you by getting part A, which is to restrain x. X has, they tell you that this area of the square must be greater than or equal to 100, and this area of the rectangle must be greater than or equal to 800. Okay. You have some constraints then on x. Let's go with the minimum first of x. If this rectangular field has to have a minimum area of 800, well, that would imply a minimum for x. What's the minimum for x? If the area of the rectangle is greater than or equal to the area of the rectangle, which is 2x squared, is greater than or equal to 800, that implies x must be greater than or equal to 20. Okay. Now the x max, this requires deduction. I love deduction. X would it be at its maximum when y is at its minimum. So we want to take as much fence as we can and give it to x and leave as little as we can for y. So let's start with the perimeter idea. The perimeter of 340 will consist of 4 y's and 6 x's. Do you agree with that? Okay. Now, x will be at a max when y is at its min. What's the minimum y? Given that the area of the square must be 100. Okay, y min is 10. That implies that 40 meters at minimum will have to be used for the Y fence, which leaves you with 300 meters for the rectangle. Therefore, X max is 50. 50. So, a Y min implies an X max. X is less than or equal to 50. X has to be between 20 and 50 in order for the area conditions to be working. All right, so that's part A. The rest of it is more typical then. Express the sum of the fields in terms of X. The area is Y squared plus 2X squared. What do I sub in for Y in order to make this in terms of X only? What did you say Y is? Based on the perimeter?
340 minus 6x over 4.
340 minus 6x over 4. Let's go with 80. I'm going to call that 85 minus 3 halves x, if you don't mind. I don't particularly care, but it might be a little useful. Okay? So then, 85 minus 3 halves x quantity squared plus 2x squared is an area function in terms of x only. Foil it out or just leave it? Just leave it. Your derivative skills are impeccable. I'm sure you can do the chain rule with that, no problem. All right, so C then. Here's where you have to read or think very carefully. Find the maximum area. The key word in there is not max. The. Not a relative maximum. The maximum. This is an absolute maximum. Absolute max area must be at an endpoint or a critical number. Now the endpoints we got in part A, 20 and 50. Part B then we need to differentiate change in area as x changes configuration would be 2 times 85 minus 3 halves x to the first times the inside derivative, negative 3 halves, plus 4x. Do you agree with my derivative? Correct me if I made a mistake, which is entirely possible. If I divide a 2 out, then I'm going to distribute negative 3. So I'm feeling like that's negative 255 plus 9 halves x plus 4x equals 0. Again, if you see a mistake I made, correct me. Okay, I feel like that's good. So 255, this is 8 halves plus 9 halves is 17 halves x. X is 255 times 2 17ths. Does 17 go into that evenly? I believe it does. Jackpot. 1, 5 times, I feel like x equals 30 is a critical number. So great, I have 3 candidates. I need to find the area at 20, the area at 30, and the area at 50, and make my call. You may use a calculator to evaluate those. Actually, is it ugly? Can we do that mentally? Well, that should get you started. You good from there?
Yes.
I don't even care. If you just leave it there, I don't care. As long as you understand what you're doing. Are you with me? All right. 69. Bless you. 6917. Is that still a question?
Yes.
Does 18 go with it? I have them listed together, but are they separate?
I don't
So
think
they're
they
separate questions.
Oh, okay. I just
Start
listed
with the 2
them.
problems that are
I don't know why. All right. Use calculus to find the area between 2 over 1 plus x squared. Okay, so this is actually, you don't even, well, maybe you do know it. That's a really famous graph. It's called the Witch of Agnesi. It has to do with some kind of translation error between Italian and English. I don't remember the story, but it's a pretty famous graph. It was the original basis for the bell curve, but the bell curve is actually far more complicated than that, the Gaussian distribution. But it looks like that. I know it feels like it should have asymptotes. Why doesn't it have vertical asymptotes?
The denominator is
The denominator has no real. Right?
All right, so then, x squared looks like this. Those functions are both even. We could use symmetry here, but let's go with area. These rectangles. It would make more sense to me to use x because it's one region that way, or one integral versus two for y. Y just wouldn't make sense. So area is the bases of each rectangle are dx. And what's the height of each rectangle? Upper minus lower to make positive.
So the 2 over 1 plus x squared.
2 over 1 plus x squared is the upper, and x squared is the lower. Now, you might have done that. Does anybody have the intersection points? Are they 1? Tell me there's something nice. 1? Negative 1 and 1? That's right. All right. Maybe you got hung up on the antiderivative of that first one. What's the antiderivative of that first one? What? What is it?
2 arctangent.
Arctangent, yeah, 2 arctangent, or inverse tangent if you like, minus 1/3 x cubed. Okay, so that should get you going on 17. Part B is just checking with your calculator. Very good?
Yeah.
Okay, 18. Let me just go here so you can still see that. 69, 18. Definite integral. So you have this x equals y times y minus 1. This is obviously a relation, not a function, at least a function of x. It's definitely a function of y. You have y-intercepts of 0, 1, and negative 2. Question is how to connect the dots. This is how I would think. I feel like if you put in big y's, you get big positive x's. So that feels like it should be here. So I think it's going to go this way. Cool? Now it says then, write a definite integral that gives the fourth quadrant area. Okay, now, you definitely would use y here because you can imagine how hard it would be to solve 4y in terms of x. A cube, that would be nasty. You want to use y. If you want to use y, then your rectangles go this way, which means you're going to use dy. Now the only question is how to make those positive. Are these the way they are going to be positive x's anyway? X's now, not y's. Are these positive x's? They are, okay. So in terms of making these positive, this is positive in that fourth quadrant region. So you don't have to do 0 minus or anything like that. There are already positive outcomes there. And so you would just say the curve. What are the limits of integration? Negative 2 to 0. Okay. I'm going to mention this also just because I remember some of you in your integrals don't put differentials. Just take off of that. And so, yeah, if you on a test, on a homework, on a test, if you forget differentials, you lose a lot of things. Okay? It's kind of important. I don't have time to do these guys, but I can try and do them in 7th and post them in 7th. How's that sound? Post during 7th. Okay? If you, you have mu alpha theta. Oh, sorry, as far as mu alpha theta, those of you who have mu alpha theta, you need to sign up with me because I'm on your schedule. Just poke your head in and say, I'm going to mu alpha theta, so I can mark it right here. Okay? How about I do that?
Anyone has any questions? Please we ask. If anyone has any questions, yes.
Oh, yeah, I couldn't find that function. So it's 72. Sorry, your homework is 72. 69 is due today. I want 69 today. Right.
I can do it now, but I have to go through to make myself
Oh, I see. That's what you're. Here, if it's dead, yeah, I was gonna say, here, why don't you just. Ay, ay, ay. Okay. So. I'll post everything. I'll try and get you some of the stuff ahead of time, at least the papers, but you remind me. Absolute. Oh man, you guys are killing me. It is dang good thing this is early in the year. If this was in April, I would have substitutes. You too?
No. So I have a meeting.
I'm on this Friday.
All right. I'm sorry.
So I have a meet that's doing some flower today. So can I give you 69 and 70 tomorrow? Thank you.
Would you write a note when you go to turn it in so I remember?
Yeah.
Oh yeah, that was basically 2 more years.
This is Friday, you said?
Yeah.
Okay. Will you be here before you leave, or are you gone all day? You won't be here. It's
Yeah, I
for
won't
you.
be here at all.
Okay. All right. I'll post a reminder. Okay. All right. Are you going to be late now? Do you need a pass?
I would love a pass, yes.
Okay. All right. What's today? Oh, 11. There you go.
Thank you.
You're welcome. All right. Hi, people. Are you okay?
The whole punch doesn't light up.
Oh, is that about? Why don't you read? Here, I have a solution. Maybe. Here. There. Right. Wow, you're like the David Chen type. I used to have a student, David Chen. I would just randomly leave an unerased mark on my door, and it would bother him so much. This little mark was there that he would get up in class every day, and I would just leave a random mark somewhere. It would make him nuts. That's actually a great math. I would want you to. I'm very good. You're definitely not whatever.
Not wanting me to be reversed.
No, I would definitely want you to be one of those students. But I can tell you not all my students, but I want from you a first time. Hi. How are you all today? Good. So my first thing I want to talk about is, for the other class it was a gentle review. You guys not like them, so it's not as much of a review. Your class, the homework you were calling is very strong. You're welcome. Hey, I'm going to talk about this just a little here and there, so don't throw this away yet. Hello. You have the necessary? Eric. Everybody have their... All right. Now, first, I need to reset all my slides. Sorry, kind of all over the place. Man, this is yes. How are you doing today? Okay, sorry, just a second. Is this lesson recording? Oh, man, I forgot to stop my recording. Wow. Okay, bad. This is my rant. Is this my rant? No, this is my rant. Okay, here we go. This isn't, like I said, apply to you as much. But first of all, I sometimes get frustrated with what I consider an Algebra 1 approach. Now, by that I mean, if you recall back in the day in Algebra 1, the teachers there still refused to get on board and do away with practice tests. Yeah? They still use practice. Now, most of the teachers hate that because it leads to homework where they say, oh, whatever, homework can be crap. They'll give me a practice test, and then I'll really kill the practice test. Well, that is really frustrating. Now, at this level, I give you a review with the assumption that you're such a good student, you're still going to care about your homework. I'm feeling like that's slipping a little, mostly in the other class, but if I start feeling like your homework is garbage, I'm not going to reward you for that by giving you a review. Then you're on your own. Okay, I gave you the homework, you did it lousy, you can pay the price. So always, I grade really nice and easy, but don't think I'm getting a 10 out of 10, I'm doing good work, I know everything. That might not necessarily be the case. So make sure you do quality. With this homework, there were a few things that I wanted to talk about specifically. I'll use this as a reminder here. On the front, I'm on review 12 that I'm talking about, okay? On the front, number 8, it was the area between x squared minus 6x and the axis. I said this, but I'll say it again. You should never have negative area. Okay? Hey, and you should always make steps or take steps, to ensure you get positive areas. So to me, I saw a couple of people do, I don't even teach it this way because students rebelled, but I had people doing this, what I was taught is the right way. Anytime you do area, you do upper minus lower. Now in an axis case, what's the upper? 0. So you would often, many texts and many professors would say, you should show this as 0 minus the curve, x squared minus 6x, if you're consistently doing upper minus lower. Now, I would take that, for sure, I'd be joyful of that, but I would also take saying, I know these are negative x's, or negative y's rather, so I'm going to negate the function, and that will get me a positive area. What is totally unacceptable is to do it the wrong way. This has negative y values, and therefore you guaranteed will get a negative area. To do it that way, mindlessly, and then just say, oh yeah, no negative area, Rickman's weird, whatever, and just not acceptable. That's wrong work leading to right answer. That to me is garbage. You didn't care enough to go back and figure out, why am I getting a negative? All right? The same is true for 9. The area between x squared and x cubed. It was pretty easy to see that some people were thinking, well, I know x cubed is bigger, so I don't need to graph that. I'm just going to do that. Now, that's a logical thing to think. Cubed is bigger. If you do that, you get negative 112. Again, I had people just go with that negative area. Bad, never negative area. I had some people that said, oh, they just actually wrote this, negative 112 goes to 112. I don't even know what that means. That's not a thing. And they didn't actually care to go back and figure out, why am I getting a negative? It's because you set it up wrong. This person set it up wrong. In this region, what's on top? Well, In that little region between 0 and 1, squares are bigger, right? And so it should have been that. That's why you're getting a negative. My point is, go back and find your mistake. Don't just erase it. The back side is, I don't like this. I'm going to do my own thing. The back side, the first one I want to talk about is 14. Now, this is my mistake. Okay. I said starting with stating EDT. The EDT has two parts, and I think you are taking a different part than what I intended. This is what I want you to take away from this, is if the question is, what is the absolute max or min? Then my first step that I would like to see, in fact, and I will build off a point on the exam for, is the EDT, but not the first part of the EDT, the second part of the EDT. So let me clarify. The first part of the EDT says there must be a min or a max if it's continuous on a closed interval. That's good, but that's not the part I want. The part I want is the absolute extrema must be at an endpoint or a critical number. That is how I was taught to do absolute extrema probably. I believe that is good work. It's starting with the theorem that you're going to use to address the problem. I'm not going to go up, first derivative test, negative to positive route. I'm going to gather the candidates and let them fight it out in a cage match, and then conclude the absolute max is this, and the absolute min is that. Basically, it's a syllogism. If there's an absolute extrema, it must be at an endpoint or a critical number. I'm only looking at endpoints and critical numbers. Therefore, this is the max because it's the greatest of the candidates. Okay? Is that understood? The ones below that, again, this is more pertaining to 5th period. Those are easiest than 6th period. The first derivative test, when I say the first derivative test, I want your answer is a conclusion statement. If it says use the first derivative test, the ending to that is there is a max at x equals 2 because the derivative goes positive to negative. That's the first derivative test. This that's not the first derivative test. Okay, now that's not just me. That's the AP test. That's every professor I ever had. The thought is, I will not read your sign test. There are a lot of different ways to do a sign test, for one thing. I don't want to get into all the different, let me figure out what this means, okay? That's AP policy. The graders will not read your sign test. They will read your conclusion. This is for your benefit to do the problem, but I don't care about that. That's not, therefore there's a maxitude. That's not a conclusion. This is it. Understood? 17, or 18 rather, second derivative test. Some of you the second derivative test is going to be on the exam page. And some of you, your conclusions to the second derivative test are unsatisfactory. Okay? It is not okay to say max something like at x equal 2 because f double is negative. Why is that not enough? I don't care. I'll draw you a picture. Here's this, and here's 2. Is the second derivative negative there? Is the second derivative negative here? Sure. Is that a max? Sure isn't. Okay? It's not enough to say, oh, the second derivative is negative. It's the second derivative is negative and the first derivative is 0. The second derivative test requires 2 pieces of information. So you would say something like a good conclusion would be there's a max at x equals 3 because the second derivative is negative and the first derivative at that point is 0. One more thing in passing. Notice it's the second derivative test, not the concavity of that test. So I don't want to hear there's a max at x equals 3 because f is concave down there and f prime is 0. That's great. I love it. That's not the second derivative test. You're not citing the second derivative test. find me one textbook where it's the concavity of f test, and I'll use it. But I have never seen it. It's the second derivative test. Okay? How do you know it's second derivative? It's concave. Oh, because it's the second derivative's name. Cite the symbol. Understood? Yes, Mr. Rickman, you did it. And last but not least, number 19. Some of you seem like you're pretty much locked in on those infinite problems. Some of you best review a lot by Tuesday, by Thursday, because they will be on Wednesday. Okay. Tomorrow I'll have besides the problem set, I'll have a review sheet. I'm changing the schedule a little bit here. I cannot for the life of me find the fun sheet I did last year. So it's 71, 72, 73, 74, and yeah, that's all. Okay. How you doing today? Good. If you are going to mu off of theta, why don't you go for the first spot? Are you guys, is anybody closed out? Is it? I don't know. Aren't you ahead of that?
Yes. That's your first time. So you're not second.
Oh. Oh, well, I told my fifth period, sign up with me and then just stop there.
I think either way is fine.
Okay. If you want to sign up with me, if you're in mu alpha theta, sign up with me and then just poke your head in and say, hey, I'm one in mu alpha theta, so I know where you're at. Okay? I don't want to get in trouble if you're actually out smoking in the parking lot. All right. Not questions, lesson. Time to learn. Yay! Learning is your business, and business is booming. Here we go. Okay. This is on the old green sheet. This is a derivative technique problem. You know many derivative rules, and I think you saw some of these last year, so it's just a way of review. So, the first thing is I want you to be able to take the derivative of an exponential besides e, obviously. So, 2 to the x or whatnot, a to the x. How do you take the derivative? Well, figure it out. Go. Work together, math and love. All right. So, Somebody get me started. What can I do to get this derivative? Take the what? Take the natural log. Yeah, that's a good general. If you say, man, I definitely don't like that x up there, then take the natural log, which allows you to rewrite it this way. Cool. That's one way to do it. Then differentiate implicitly. What's the derivative of the left? 1 over y dy dx. And what's the derivative of the right? Natural log of 2. You're telling me I don't need the product rule for the right side? Yeah, natural log of 2 is a constant, it's not a function. Could I use the product rule? You could, actually. The derivative would be 0 and you'd be wasting your time, but, or one part would be 0. But you could do it. dy dx is then y natural log of 2, but if we write this in x terms, our final answer is to the x natural log of 2. All right. Did anybody do it a different way? There's usually one crazy person in the bunch that thinks really outside the box. Okay. One school of thought, can't remember, this is kind of a Rory Devon crazy, where'd you get this kind of thing, but say you did this. Do you agree that that's true? That's the same as 2 to the x. Okay, so if you did the derivative on that, that then would be, all right, by chain rule, it's the same thing back times the derivative of the inside. The derivative of the inside is natural log of 2, that is 2 to the x natural log of 2. And so that is indeed a way to do it. Some people just think differently. All right, I did it this way myself. So, generally speaking, the derivative of a to the x is a to the x log of a, natural log of a, in either order, obviously. All right, next idea, I believe you could also get on your own. Try and take the derivative of log base 2 of x, so that we could find a log derivative rule.